Hello my dear students, welcome back. What a joy to see you back. How was the quiz? I know, that was no quiz, wasn't it? Okay, good. We just learned the term equality, okay? Good. So you understand pretty good what's equality. Alright, in this sub-lesson, we're going to talk about linear equation in one unknown. Now let's understand the linear algebraic term, okay? Let's say for example, Mr. Mac to write 3x. Now this is called linear. The reason why this can consider a linear, because you only got one unknown. When I say one unknown, it has to have one power, okay? Power of 1, okay? Now it has a coefficient, a number coefficient 3, okay? So let's say Mr. Mac to write 8x squared. Now is this would be considered linear algebraic term? No, it's not linear algebraic. Why? That's the power of 2, okay? Because that's considered like a 2 unknown, because this is pretty much 8x times x. See that? You only can have 1. Now what about if I have 5xy? Is this considered linear algebraic term? It's not. Why? Because it's a 2 unknown. You got x and a y. See that? So this one is a linear, this one is a not linear, and this one is not linear. Okay? Now what happens if I say negative 3mn? Is this a linear? It's not. M and n, that's a 2 unknown, so it's not linear. And what about if it's negative 7m? Is this a linear? Yes. Doesn't matter about the coefficient, the number coefficient, is it negative or positive? It's the unknown is the one that matter. How many unknowns are there? 1. And what's the power? It's 1. See that? So this is a linear. Alright? Linear, okay? It's a linear algebraic terms. Okay? Now let's say for example, if Mr. Mac to give you 5x plus 7y. Is this a linear? Yes, this is a linear algebraic expression. Okay? Because you got two terms. And each term has one unknown. See that? With the power of 1. Now you don't show the power of 1, but you always keep in mind, if anything other than 1, it's not linear. Okay? Anything other than 1, it's not linear. So it has to be power of 1, which we don't have to show it 1, but you know it's there. Alright? Now look at this. You got two terms, and each term has one unknown, and that makes this one linear algebraic expression. Alright, now let's say for example, Mr. Mac to give you, let's say 4m plus 3mn. Now, is this a linear? It's not. Even though one has said one unknown, another one got two unknown. That makes this one, it's not linear algebraic expression. Okay? So, in order for a linear algebraic expression to be linear, it has both or more, has to have, the terms has to be what? One unknown. Okay, you cannot have more than one unknown. Okay, so keep in mind one unknown. All right, so look at this is a linear, this is linear, these are not linear. All right, why it's not linear? If this one got power of 2, or even if it's power of 3 or power of 5 or negative 3 power, anything like that. Okay, this will not be a linear. All right, now this one you got 2 unknowns or 3 unknowns or 4 unknowns, timesing with it. Okay, falls under not linear category. Okay, in this case same thing. Right, doesn't matter what variable, what unknown letter I use, still got 2 or more, it's not a linear. Now look at this one, m with the power of 1, that's a 1 unknown. Doesn't matter if the coefficient, the number coefficient is a negative or positive or fraction or decimal, it still fall under linear category. Okay, when we come to expression, the linear algebraic expression, now these are terms, these are linear algebraic expression. Each term in the linear algebraic expression has to have one unknown, and that qualifies this as a linear algebraic expression. Linear. Okay, now does this one qualify? No, this is not. Okay, why it's not? And this one is yes. And why this one is not? Even though one term has one unknown, but look at the other one, the adding to it has 2 unknown. So that disqualifies this to be considered as a linear algebraic expression. Okay, so it's very important. Okay, so let's say Mr. Mac to give you 5u plus 3v, and that is linear. Okay, so 5u plus 3v squared, is this a linear? it's not linear. Why? Because this one is one term, but this one is a two term, v squared, v times v. See that? That disqualifies this to be in a linear, okay? Alright, so if I negative 3 uv plus 4v, how about this one? It's not linear. Why? Because this one has a uv and this one has a v. This one is not a linear algebraic expression, okay? So very important to understand the term. For linear algebraic term, you have to have one unknown, okay? And the power has to be what? 1. For linear algebraic expression, you can have several terms, but each term has to have one unknown, okay? And that qualifies to be linear algebraic expression. Alright, okay, let Mr. Mac erase the board. Now let's talk about linear algebraic equation, okay? And I'll be back with you in a few seconds. Alright, my dear students, earlier we talked about linear algebraic term, linear algebraic expression. Now we're going to talk about linear algebraic equation. See the word equation. So that means when I have the expression, the linear algebraic expression, which has the linear algebraic terms, I'm equating with something, and that's why the linear algebraic equation comes in. Okay, let's say for example, Mr. Mac to give you 3x plus 4 equals to, let's say 12. See that? I'm creating an equation. See that? 3x plus 4 equals to 12. That's an equation. That's a linear. Why is it linear? Look at this. X. And look at this term. How many unknowns are there? There's only one unknown. Okay? There's only one unknown. So x is the one unknown. Okay? Now let's say Mr. Mac to give you 3x squared plus 4 equals to 12. Now, does this qualify as a linear equation? It's not. Why? Because you got x squared. X squared, it says a 2 unknown. See that? Okay. What about if I give you, does this qualify? It's not, because you got 2 unknown, x and y. Okay. So it's very important. Okay. What about this one? Does this qualify? Yes. Because each term has one unknown. See that you can have 2 unknown, but each of them in the different terms. Okay, see this one's in this term and that one's in that term. Alright, as long the term has one unknown, and that makes this one linear equation. Okay, so linear equation. Now I can write it so many different ways. Let's say Mr. Mac to give you 6x equals to negative 5y plus 2. Now is this a linear equation? Yes, it is. It's just that the way it was arranged. See that? Mr. Mac put on this side 6x equal on the other side with a negative 5y plus 2. Now look at this term. How many unknown are there? Only one. How many unknowns? 1. See that? So that qualifies. Okay? That qualifies that this has a linear equation. So the key thing I want you to remember, okay? Each term has to have one unknown. That makes this one exactly linear algebraic expression, linear algebraic equation. Okay, so the word equation, so we know the term. Okay, so let's say if I give you 5x, and that's the term. If I give you 5x plus 2y, that's the expression. Okay, and this one is the equation. Okay, so this is algebraic linear, this is a linear term, and this is a linear expression, and this is a linear equation. Why is this one equation? See, that's an equal sign there. That makes it equation. See that? So linear equation. Alright, good. So now let's create some words that we can translate that into a linear equation. So now let's talk about writing a linear equation from a statement. Okay, let's say for example Mr. Mac to tell you double a number, add 6 equals to 20. Alright, double a number. Okay, the number I'm saying is going to be the unknown, which you don't know what the number is. Okay, that double a number, add that with 6 equals to 20. Okay, so let's write that down. Double a number, add 6 equals to 20. See that? Now, is this a linear algebraic equation? Yes, it is. Why yes? Because look at this term right here, x with the power of 1, it's only one unknown. That qualifies this into a linear algebraic equation. Okay, very important. All right, let's do another one. Okay, let's say for example this time Mr. Max said take a number, divide that by 2, subtract that by 12, and equals to 25. How do you do that? Right, it's pretty easy. Divide a number by 2. A number that I'm talking about is the unknown, because you don't know what the number is. So you give a letter. Now it doesn't have to be x all the time. You can put an m. So I can say m divided by 2, and then I said what? Subtract that by 12. Okay, subtract that by 12 and equal to 25. Right there. See that? Right there. Just the word expresses, just exactly translate the statement that I write into now linear algebraic equation. 5m over 2 minus 12 equals to 25. Okay, now this is also can be written as 1 over 2m minus 12 equals to 25. See that? Because you're halving the m. Now this is a coefficient right there. See, the coefficient for this one unknown can be number, positive or negative, can be a fraction or even decimal. See that? So it doesn't matter with the coefficient number wise. It's the unknown has to be 1 in order to qualify under the linear equation. Okay, linear equation has to be one unknown on the terms. Okay, and each term there should be one unknown. Alright, good. Well, let's do this. Mr. Max is going to list out all the terms, algebraic expression, linear algebraic expression, and then linear terms, linear algebraic expression, and linear equations. Okay, and I'm going to have so many different. I want you to identify which is linear, which is not linear. How do we do that? Alright, okay, we'll do that as a hands-on practice. Okay, I'll be back within a few seconds. Alright, my dear students, are you ready for some hands-on practice? Alright, good. Well, let's call Pablo out, okay? He's been busy. Come on over, Pablo. Come on over. Our dear students are ready for some hands-on practice. Alright, my dear students, once Pablo hand over the worksheet to you, be sure to pause the video and then have fun with it. And then once you're done, and then come back and invite Mr. Mack in. And then we'll have fun together, alright? Here it is. Have fun. Whoa, that's good. She gave you some hands full of questions there. All right, let's do the first one. Okay, Mr. Mack, let's read out the first question on the board. Okay, so let's do that together. The first question says, determine if the given terms, expressions, and the equations below are linear or not linear. All right, so we got terms, expression, and equations being listed out. So we want to identify whether they're linear or not linear. Okay, so first, let's understand what is linear. In order for the term, expression, and the equation to be linear, there should be only one unknown. Alright? So with that in mind, let's look for it. Okay? So this is called term. And how many unknowns are there? Only one right there. See that? T. Doesn't matter about the coefficient, it's a number coefficient, doesn't matter. It's the unknown is the one that matters. So this is linear. Alright? Very good. This is linear. What about this one? This is expression. Okay, we got one term and two terms. All right, there are two terms. All right, so first term you got one unknown. Look at the second term, has two unknown. That disqualified this to be a linear. So this is going to be a not linear. Right, so we're just going to put not. Okay, so this is not linear. Now what about this one? You got 0.803 B. Doesn't matter with this coefficient, 0.803, doesn't matter. Coefficient doesn't make the decision, all right? The number coefficient, it's the unknown is the one that makes the decision whether it's a linear or not linear. And this is a term, so it's a linear or not linear, all right? So this one is a linear, okay? Because we got only one unknown. What about this one? This is an expression. We got one term and then in the second term. So this makes it two terms. And each of them has one unknown. Exactly. This is linear as well. Now, does it matter with the divide by 7 and all that? No, because we can break it up. So this is going to be negative 4 over 7u plus 1 over 7m. See that? So, one term which is one unknown, second term as one unknown. Alright? So don't let the way it's been set up intimidate you, make you think, whoa, got to be something there. No, look for the terms. Okay? Once you identify the terms and then look for the unknowns. How many unknowns are there? Alright? Like for example, this case, this is a equation, alright? Linear equation. Why is it linear? Because the term here only has one unknown. See that? So that makes it linear. Okay? Now let's look at this one. Now this is also an equation, alright? Algebraic expression. This is an algebraic equation. So you got two terms. It doesn't matter about the arrangement, okay? So even though the equation says there's one term here, one term over there, on the other side of the equation, as long as each term has a one unknown, alright? Don't let these fractions intimidate you, alright? Alright, doesn't matter. It's the matter is look at the terms, alright? So that makes it this one linear as well. Now what about this one? You got 1, 2, there are two terms. The first one, you got one unknown, and second one, you got two unknowns, because t squared, which is t times t, that disqualifies, okay? So this is not a linear, okay? And what about this one? 5b equals to 3ac plus 2. One unknown, two unknowns. See that? That also not linear. See that? Pretty easy, isn't it? Very straightforward, okay? Alright, the key thing is, look at the terms and make sure they have one unknown. Alright? So if it's an expression, look at the term. If it's an equation, look at the terms. Alright? Good. Okay, let's do problem 2. Problem 2 says write an equation for each of the following statements, okay? Now the first statement says double the number plus 5 equals to 18. So let's do that. The number is the unknown, so you can assign any variable you want, okay? So let's do problem 2a. So 2a, we said double the number, so let's say m, okay? We're going to double m and then plus 5 equals 18, equals to 18 right there. Now is this a linear algebraic equation? Yes, this is a linear equation. Why? Because it's got one unknown. Alright? Okay, let's do the second one. Divide a number by 5. Subtract 4 equals 9. Always try to read the whole thing so that you understand. Okay, so we're going to divide a number by 5. A number, again, we're going to assign unknown. Alright, so let's say u. Okay, so we're going to divide a number by 5. So we're going to divide that by 5. And then subtract 4. So we're minus 4 equals 9. See that? Very straightforward. Just exactly it reads out. Okay? See that? Just exactly it reads out. It said divide a number which is unknown. We're going to give it as a u by 5. Okay? So we're going to divide a number by 5 and then subtract 4. See that? Subtract 4 equals to 9 right there. Okay? Alright, let's do C. A number multiplied by 3. A number multiplied by 3 plus 6. Okay, so let's do C up here. Okay, so a number multiplied by 3, a number. So what unknown shall we assign? Okay, let's say S. Okay, 3S. Alright, 3S, because we multiply that by 3. Okay, so and then plus 6. So we're going to add that to 6 equals twice the number. Twice the number, the same number right there, twice the number, okay, minus 8. Now, is this a linear equation? Yes, it is a linear equation. Even though they are the same unknown, doesn't matter, but they are in different terms. See that? That's a different term. Okay, so you can have same unknown, but as long they're not together in one term, but in a different term. Okay, that's the key thing. So this is a linear as well, linear equation. Alright, okay, because keep in mind, see that? Equals twice the number, is referring to that same number. Alright, okay, or if I say twice different number, okay, another number, twice another number, minus 8, then you give another unknown. Okay, this case is referring a number and the number. That means the is referring to the number initially you started with, which was S. Okay, good. Well done, good job. I know you did good. All right, okay, good. Well, that should tells you, yeah, Pablo already told us. Okay, it's time for quiz. All right, my dear student, have fun with the quiz and then come and see Mr. Mac on the next sub lesson, and I'll be here waiting for you. Okay, have fun.